Hello, my name is Rishi. Today I'll be walking through Deep ML problem number 23. The problem is Softmax activation function implementation. Our task is to write a Python function that computes the Softmax activation for a given list of scores. The function should handle numerical stability by preventing overflow when exponentiating large values, and we have to return the softmax values as a list of floats. I'll be doing this in PyTorch. Now, they do give us torch.nn.functional, so we could do torch.nn.func, or we could do f, because it's imported as f, dot softmax, and then torch.tensor scores dtype equals torch.float 32, and return that, and we'd be done. But that's boring. So that's one solution you could have, I think. Hope this works. But there's another one I'll walk through as well, which is doing softmax manually so we can understand it better. Oh, it doesn't. Oh, tensor doesn't have a round. Oh, dot item this. Either dot item or dot to list. Yeah, dot to list. Yeah, okay, so we can see this works perfectly using just torch.nn.functional, but we can also implement softmax ourselves. So let's do that. So we have to do it and handle numerical stability by preventing overflow. So the way to do that is this formula right here. Softmax of the scores is equal to e to the scores minus max of the scores divided by the sum of each element in the scores when exponentiated. You notice that softmax creates a probability distribution. Because it creates a probability distribution, we can subtract the same maximum value from all scores before exponentiating, and that won't change the resulting distribution, because everything changes the exact same, so the probability distribution does not change either. So we can implement this in a couple of steps. First of all, I don't know why this indenting is weird, but anyway, first step is convert scores to tensor. Second step is find e to the z minus max. Third step is compute softmax. Fourth step is return result as a list of floats. Because remember, our return type is list float. And I'll just note this works perfectly well too. So convert scores to tensor. So we know scores is a list of floats, so we use dtype equals torch.float 32. So scores equals, where scores t is equal to torch.tensor, scores dtype of torch.float 32. Okay, now find the exponentiated value of e to the z minus max of z, where z is scores. So xval is equal to torch.exponent scores t minus torch.max of scores t. Next step, softmax. So softmax result is equal to xval divided by torch.sum xval, with the axis being along features. Features will be the last dimension in xval, and then keep dim equals true, because we do not want to eliminate features, and we don't want to eliminate the other parts of the softmax, or parts of the shape of the input data. Now return softmax result as a list of floats. So we do to list, and this should work as well. Yep, we can see this also passes all test cases, just as well as torch.nn.functional.softmax of torch.tensor scores dtype torch.float32.2 list. So yeah, all code for this will be in the GitHub in the description. Thank you for watching.